Just let me know if you guys can hear me. Please let me know if you guys can hear me. Can you hear me? Let me know if you can hear me, please. Can you hear me? Let me know from the comment section. Please, you can write application of derivatives. But before I start, please let me know if you can hear me. Okay, someone said yes. Okay, let me hear from other persons. Okay, please say yes. From other person, please. You can share the link so that some persons will join. Okay, Blessing said yes. Okay. Please just share the link, please. Our intention here is to treat most of exam-like questions on application of differentiation. So we have to know when to apply differentiation. Okay. Not only that, we have to also solve some questions on differentiation. Okay. Please just share the listen so that we can move ahead. I'm just seeing few persons here. Okay. Please write application of derivatives. Application of derivatives. Okay. Please, can you hear me? Let me know if the network isn't working. Can you hear me? Can you hear me, please? The network is very bad. Okay, someone said yes. Okay. Let's continue, please. Let's continue. Okay. Please write. Let's continue, please. Please write. Differentiation can be applied in so many areas. Differentiation can be applied in so many areas. Now, the first area we can apply differentiation is one gradient or slope. Or slope, or you can also call it tangent. Very important. The second is stationary point. Stationary point. The third here is rate of change. That is mostly on kinematics. That is the fourth here is under geometry, where you will have equation of slope, equation of normal. That is equation of slope and normal. So in this video, we're gonna focus on these applications here. Please take notes. So let's take the first one here. Please, if you can hear me, let me know perfectly so that I will know if there is any issue from this end. Please, can you see the board clearly? Can you hear me? Can you see the board clearly? Okay, someone said yes. Okay. Now, let's take the first one here, please. Just write gradient or slope or tangent. So we have to know how to apply differentiation on that slope and on that tangent. Okay, we have to know how to apply differentiation on that slope and on that tangent. Okay, so class, please write the first one there, gradient or slope or tangent. Please take note of this, please. The word slope is the same as gradient and is the same as tangent. The word slope is the same as gradient, is the same as tangent. Please take notes. So, but before we solve a question here, let me explain more about slope and tangent. Now, from the first one here, that is gradient or slope or tangent. All right, let's take the one we know first. We know more about slope here. Now, anything about slope is the same as this, is the same as this. Please take note. But let's take the one we know first, which is slope. So we see that slope here, from what we know, is the change of y over change of s, which is the same as y2 minus y1 over s2 minus s1. All right. Now, this can only be applied when we have 2 points given to us. If you have point S1, point S2, point y1 and point y2 given to you, you can use this formula as your slope. For example, if I have something like this class, I have coordinates 2, 3, I have 5, 6. These are 2 points here given to us. So if you're asked to find slope or gradient or tangent, you can use this particular formula here to solve for that. So of course, this will stand as your S1, this your Y1, this will stand as your S2, and sorry for this. This will stand as your S2, this will stand as your Y2, and you replace it here. You will have the answer. But if the function, or if the equation is in a function, if the equation is in a function and you are asked to find slope or gradient or tangent, if I have something like this is a function here, y is equal to 2x raised to the power of 3, and you're asked to find the function, the slope of this guy here, we differentiate to get the slope. So we have to find the dy, which is the same as change in y over change in s. So whenever the expression or the equation is given to in terms of function, you differentiate to get the slope. But if it is given to in terms of point, maybe the 2 points are given, you use y2 minus y1 over s2 minus s1. But let's have a question here to understand this properly, please. Please write question 1. It said find the gradient of y is equal to 3 s raised to the power of 4 minus 2s all raised to the power of 6 at s is equal to 1. We are asked to find the gradient of y equal to 3s raised to the power of 4 minus 2s raised to the power of 6 at s equal to 1. So remember that this particular equation is given to us in terms of function, not in terms of points. S1 is given to us, but Y1 is not given to us. Nor is S2 and Y2 given to us. So at this point here, we have to differentiate this equation here and later replace S as 1. Okay, so whenever you differentiate this and replace S as 1, that particular value will be our gradient or slope. But you can also use calculator to solve this. How do we use calculator to solve this? It's very simple. Whenever you are asked to differentiate and the points are given to you, this is what you have to do. You have to use your calculator to solve this. So class, which one do you prefer? Is it the solving or the calculator? Let me hear from you. Is it the solving manually or using calculator? Which one is better? Okay, which one is better to solve this? Do you prefer the calculator shortcut or manually? Please let me hear from you guys. Okay, someone said both. Okay, it's calculator. Okay, let's use calculator to solve this. But remember, we only use calculator here because the points are given to us here. We'll use both of them though. Okay, now let's use calculator here. This is your calculator. I don't know if you can see it clearly. Okay, this is your calculator. Now, how do we solve the ds using calculator here? Class, you only use calculator to solve the ds if you are given a point, if s is given to you. So this is your calculator here. Please just permit me. And in your calculator, you will see derivative here. That is second row here, 1, 2. After calc, you see derivative, and derivative is actually at the front of integration. And I told you guys that to perfect your calculator, there are 2 features you have to understand. The first one is the shift feature. The second one is the alpha. So the shift here is yellow. So to get anything that is of yellow here, you press shift to get that stuff.
So the color of this DDS here is yellow. So I'll press shift to get this. But before then, please make sure you on your calculator. I don't know if you can see properly. So you press this shift here to get the DDS. Oh. Okay, please, in case you are pressing and you can't get the DDS, please try to move your calculator from complex in case. Okay, now you press shift DDS. So inside the box there, you will write what is given to you there. That is 3S, you know, FS now, that uh, alpha 4. You press this button here to get any power. That is S box here, S for 4. Use your control button here to take it down, to take the cursor down. That's minus 2s. Please take note of this. You close your bracket again. You have to bring up another bracket. You close your bracket, close your bracket, raise to the power of 6. Okay, this is how you will put this in your calculator. Sorry for this, let me just write it where, so for those that don't understand properly, when you press the D over the S, they will bring up bracket open here, close here, bring out something like this, boss of S equal to something like this. Okay, so what you have to do here, you have to create your own bracket again. That is this bracket here. That is right, 3S raised power 4 minus 2S. You get this one here is from the calculator. This one is one you created for this. You close your bracket, raise power of 6. This one is the natural one already. Okay, now the next is to shift the cursor to this point here to put 1. The 1 is as a result of this one given to us here. So if S is equal to 2, you here will have to be 2. Okay, so I'll shift the cursor to that end. You press 1 there, equal to. So they gave us 56.999. So when you replace your calculator, when you approximate, that means our dy dx, you can see how fast it is. Our dy over dx is equal to 60. So remember the dy dx here is standing as the slope. So this is how we solve dy dx using calculator. Please, do you guys understand the calculator shortcut? Do you understand the calculator shortcut? I should come again. But can you hear me when I was explaining? Can you hear me? Please, can you hear me? Okay, let me come again. But before I come in, are you with your calculator? Don't just use your listen. Are you with your calculator? Are you with your calculator? Some of you are not with your calculator. So still listen. This is very simple. This is your calculator here, in case you're with calculator. But if you're not with your calculator, please don't just stress me. Okay. Now the first thing here is to um click on shift to get the D of the S, and then click on that integral button there. You get. So when you click on that, let me just clean my own tool. We are trying to solve this question here given to us, this one here. We are trying to solve this one here given to us here using calculator. So it's very important for us to use calculator here because the value of S is given to us. Okay, so you on your calculator, you press shift, you press this button here, this one here, you have this stuff here. But remember, this question here already have brackets. So you put your own bracket for this 3 of. Now the next is to press S. S, you can get S from when you can get S when you press your alpha of S here, this S here. So you press alpha S raised to the power of 4. We are trying to type the equation. Okay, raised to the power of 4. So how do we get raised to the power of 4 here? You press this button here, this S box. Please just check your calculator to flow up. This that is raised to the power of 4. This S box will get any power at all, raised to the power of 2, 3, 4, and all. Okay, the next here is to type minus 2s, that is minus 2s. But before then, please try to take the cursor down, that is by pressing the control button. Okay, minus 2 alpha s. You close your bracket, that is the one you created. Raise to the power of 6, you press boss raise to the power of 6. So you take the cursor to this point, to the ending point. Now, when you get to the ending point, that is s equal to boss, you impute 1, that is this one given to you here. If it's 2, you put 2 here. You can see what I'm doing here. You put 1 equal to, they gave us 59.999, which is the same as 60 approximately. So this is how we solve differentiation using calculator. But we only solve differentiation with our calculator if the point is given. If the point is, cannot do that. So please let me hear from the comment section there. Do you guys understand now? If you don't understand, that means you need prayer. Do you guys understand now? Do people understand? Okay. Someone said yes. Another person? Okay, you guys understood. Okay. Now let's move to the next one here. The wide S is representing the slope there. Please take note. That the wide S is representing the slope. So let me clean the board for us to solve question 2. Okay, class, question 2. A curve. Remember, when you're applying differentiation, it means that you already know differentiation. And I know I have sent a lot of videos on differentiation. So you just have to click the subscribe button to get most of the videos on differentiation. Okay, if you don't know much about differentiation. So they said a curve has equation s raised to the power of 3 plus sy plus y equal to 3. Determine the slope at the point 1, 1. So class, we are given a question here. They said a curve has equation s raised to the power of 3 plus sy plus y equal to 3. Determine the slope at the point 1, 1. But I have to make you guys to follow up here, because if I don't make you guys to follow up, you just learn and you will not understand anything here. So class, this word slope here in this particular equation, is it y2 minus y1 divided by s2 minus s1, or is dy dx? Which of them are we going to use? Is it y1 minus y2 over, y2 minus y1 over s2 minus s1? Is it the slope we are going to use, or we are going to find dy dx? Which of them, please? I'm listening, yeah? Yeah, answer, please. Can you people hear me? Correct. Someone said dy dx. Now, it is dy dx because the only thing given to us there is only s1 and y1. There's this point you are seeing that is given to us here is only s and y only. We don't have the second s and y again, okay? So at this point, we differentiate. And from what I told you guys about differentiation, now whenever you are asked to differentiate any function, the first thing is to identify the function. Please take note. So let's identify this function here, class. This function here is implicit function. And of course, there's a short way to solve an implicit function. What is an implicit function? The word implicit means input of multiple parameters. So when we have two or more parameters in a function, we call that implicit functions. Please take note. So if you look into this function here, we have s and y. So differentiating this here, we use implicit functions. So class, before we solve this here, solution first. Okay, the question now is, how do we differentiate an implicit function? So we are running out of time here. There's no need for us to start differentiating and all. It's the shortcut method we are going to use. Okay, now what is the shortcut method here? Our dy dx for implicit function is equal to minus f prime of s over f prime of y. Now what does it mean here? This prime here simply means differentiation. So it means differentiate only for s, and that result will be at numerator. Differentiate only for y, and the result will be at denominator. Please take note. So from this equation here, we have to differentiate only for s only. But before you do that, you have to make this equation here to be standard. So how do we make an equation to be standard? We take anything that is of at the right hand side to be at the left hand side. So the equation will be, please permit me to clean the board. A class. So the equation will be that's plus sy plus y minus 3 is equal to 0. So I took that 3 at the right hand side to the left hand side. When you do that, we have this equation to be standard. So before you use, listen to me carefully, before you use that shortcut, the first thing you have to do is to take anything at the right hand side to the left hand side. Please take note. So we can now use the shortcut formula, that is dy over dx will be equal to plus minus f prime of s over f prime of y. So let's differentiate only for y. Now let's select first before we differentiate this y, this y. So differentiate this normally, the way you used to differentiate, I will have this to be minus into 3s square. Now differentiate this guy here, since it consists of y here, differentiate this, you have 1 times y plus y. Please take note of this. Now, I know most of you guys are confused here. Differentiate this s only. You have 1. So the total result of this part here will be 1, that 1 times this y here. Please take note. Over, there's no other y here. Over. So there's no s here. Y. There's no y here. There's y here. Differentiate this y here, this y here. You have 1. The total result will be this times this, which is what? S. Differentiate this y here, we have plus 1. The plus is this plus here. Please take note. So this is how we differentiate an implicit function. Please let me know light. Let me know if you guys understand or I should throw more light. Because you must see an implicit function. Let me know if you guys understand or I should throw more light. I should throw more light. Okay, you understood? The next person, please. Okay. The next person, please. Okay. So your problem is differentiation. Just hit the subscribe button and you get the full video on differentiation. Okay. Now, remember, listen, to differentiate, take the power down to the base, subtract 1 from it, you will get this part here. So this is the one we are targeting here. If you are differentiating s, there's an invisible one here. Differentiate this s, take the power down to the base, and subtract 1 from it, it will be 1 times s. That's what we are just doing here. Whenever you have differentiation, subtract 1 from it, you have the result of s and y. Remember, they gave us this to be 1, 1, which means that s is equal to 1, y is equal to 1. Here, if you replace the y, which is this is equal to in let's impute into 1 all squared here. Anywhere I see s, you put 1 here. 1 plus. Class, let's simplify this here, class. 1 all square is 1. 3 times 1. 2. 3 is 1 plus 2. Minus the send here. And find the slope of the curve s sy is the point 1. Everybody. Okay, I see. Sorry. Can you hear me? Well, sometimes.
And you put and send to me. S squared is equal to what? Are you done? Once what? How much just? I'm sorry that okay. Hear me now? We saw it together. Okay, wait, let me stop you. Okay, can this one now? It's okay now. Is the voice minus 5? I think minus 4. Particular function. Sorry, the particular this particular implicit function here is slope. Slope is right here that function. The, the okay, let this here for solution y s to minus of f these signals. Are we only for these parts numerator part only for to have but remember this everything at the left hand side make standard that this uh, um, f squared plus minus so that means sc will equal to 2 differentiate this is so that we have plus 1 are always there is combination of y and only one only this here and it's not only so that is what times what is it is y this thing so I'll have this to be differentiate to have let's differentiate to have the denominator so the this y here, but I will not differentiate s. Okay, so 1s different plus, say it is minus this plus have answer. But here we are given the value of s. This 2 s to 1, y is equal to, well, let me just get to plus. Let's see, that is the y over equal to plus. So, s plus y over is 1, y is 2, that is I will have 2 here. So the simplify what be minus in 1 is 2 is 4. 2 2 plus 1 is 5. So minus 4, 5. Please take notes. So let's consider kinematics. Here, kinematics. But here the, can you get, like, can you people hear me? Can you people hear